Let's start with the first statement we're given. Segment AB is perpendicular to segment RS. So, I don't know, I guess we're using probably the definition of perpendicular lines. So what does that mean? If you need to pause the video and go see what type of conclusion we're going to make, you can do that. We're going to be saying we have some right angles. So what right angles do we have? And maybe you have an idea where this is going to go and you do something else first, but I like to just take what they give me and see where it leads me, and then worry about how it's all going to fit together secondly. So I have the definition of perpendicular lines. I should be saying a couple angles are right angles if you saw that on your gold sheet. And the angles we're going to say are 1 and 2. So angle 1 is a right angle. Angle 2 is a right angle. Now, to prove these triangles congruent, I want to get congruent parts, angles, sides. So maybe 1 and 2 correspond. So I'm going to go back and check. They're trying to prove R to A to B, S to A to... So yeah, R is going to correspond with S. This is going to be a reflection, and angle 1 will correspond with angle 2. So if I can prove that 1 and 2 are congruent, that will count for one of my sets of corresponding congruent parts. What does it mean to be a right angle? Measure of angle 1 equals, that's right, 90. Say the same thing about measure of angle 2. That's what it means to be a right angle. And then if they're both 90, well, we should be able to say then they're equal to each other, just replacing the 90 in one of them for the other angle. I replace into the first one, so it'd be in the order 1 to 2, but it wouldn't really matter because the order that we get them congruent in is irrelevant. We just need to make sure we can get them congruent. And the reason we need to change it to congruence is the conditions to the side angle side or side 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 says that you need corresponding congruent parts. So I knew 1 and 2 corresponded. I need to show they were congruent to be able to count them as one of my sets of angles in getting to angle, angle, side, or angle, side, angle, that type of thing. So what do? We just change it to congruence once I had the measure equal. That's definition of congruent angles. Says if you know the measures are equal, go ahead and say they're congruent because that's what it means to be congruent. That's one. That was two, like 4 different steps just to get to the first one. So hopefully the next ones come a little bit quicker. The next thing that we're given is, let's see, B is the midpoint of RS. So if the B is the midpoint, right in the middle of R and S, what should be true? Measure of RB should be equal to the measure of SB. Or if we want to say they're congruent right away, which I do for this because I want corresponding congruent parts, I'll use the midpoint theorem. We have a midpoint theorem that says they're congruent. Now remember, when you name things congruent, it has to imply what corresponds and how. So I'm going to say segment RB is congruent to segment, and then when I name the second segment, make sure, what does R correspond to in that picture? If you're not sure, from the first triangle we have R, from the second triangle we have S. So I know R should correspond with S just by the way I name it. B, actually, if you look at the way they name it, corresponds to itself. That is a set of corresponding sides. We've got 2 done. Need 1 more. But that's all they gave me. So there's a few things that we need to be looking for that we should know without them telling us even. Vertical angles. Don't have that here though. Linear pair, but the linear pair I have here, I already know that 1 and 2 are congruent. So I've kind of been there, even though I didn't need to say that they were a linear pair. I've used those 2 angles that form a linear pair. The one we're missing, they share a side. So I can say segment AB is congruent to segment AB. This is just a reflection. If you look at the way they name it, A corresponds with A, B with B. So I don't have to worry about naming it all funky. It's just equal to itself. That's a set of sides. And it looks like I need to be careful that I check my picture to make sure this works, because remember, there is no swear word theorem. And right now I have the right letters for that swear word. So I'm going to check to make sure everything's in the right spot. But the order we get in, A through S here, when we're getting those different parts, that's not significant. What's significant is what we see in the picture. See, we used RPC, reflexive property congruency, for that last statement. And I have enough stuff, so if this works out, we should be able to say triangle RAB is congruent to triangle SAB. We just need to know why. So let's check our picture. I've got the side, angle, side, and in the picture, it's in an order that's okay. Side, 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 triangle congruency says those two triangles should be congruent then because they have just the right hearts.